But now here, interhalogen compound. Just see once again, what is an interhalogen compound? When one halogen can combine with another halogen, they can form this kind of the compound, X, X dash. Actually, X is a larger size of halogen and X dash is the smaller size of halogen. So they can form the compound X, X dash, X, X dash 3, X, X dash 5, X, X dash 7. X, X dash is a interhalogen compound obtained at the ground state. XX3 at first excited state, XX5 at the second excited state, XX7 at the third excited state. How you can see here, we know general electronic configuration of these seventh group element is NS2 and P5. That means in ground state you can see we are having only one unpaired. So it may gain one, it may lose one. So based on that, it has a tendency to form compound of XX dash. In first excited state, one of the electron from the p orbital gets excited to d orbital. So total number of unpaired, how many we have? 3. Based on that, its oxidation state is a +3. That means it can form the compound of XX3 compound. Second excited state, one more electron from p excited to d. We are having 5 unpaired, oxidation state +5, and it can form the compound XX5. And in third excited state, one of the electron from s orbital, it get excited to the d orbital. Total number of unpaired, how many? 7 are there, and hence it can form the compound X7. So they can ask you in the exam, X-7 is a compound obtained at which excited state? So answer is, it is at the third excited state. Now we'll see one by one about this interhalogen compound, what will happen. One example I'll show you, beta. Or it's a point was given in our book as the ratio of or ratio between as the ratio between radii of larger size to smaller size increases, then number of atoms per molecule also increases. I'll give you example, beta. Suppose I will talk about the larger size chlorine and smaller size fluorine. I'll talk about the larger size iodine and smaller size fluorine. Obviously, beta, this iodine and fluorine will have a greater ratio of radii than this chlorine to fluorine. Hence, the compound formed by that iodine and fluorine is a IF7. But compound formed by this chlorine and fluorine is not maximum up to this ClF5. We cannot write ClF7, but here with iodine and fluorine we can write IF5, even IF7, and write clearly here it has a tendency to form as a IF7. Why? Larger the size of the halogen and smaller the size of the halogen. If the radii, see, if the ratio of radii between larger size to smaller size increases, that means number of atom per molecule also increases. Hence, iodine to fluorine will form the compound as a IF7, but chlorine to fluorine can form the compound as a ClF5. It is a one case will be there. Second case they will ask about here, the one more part, among these one, which is more reactive and which is a less reactive. But I will tell you, interhalogen compounds are there. It will be more reactive than that of the halogen. Why it is like that? Because interhalogen compounds are which one we are writing here. These interhalogen compounds are more reactive than that of a halogen. So one more point to remember. Interhalogen compound IHC. These are these are these are more reactive than X2 means halogen. But one exception is there for the fluorine. other than fluorine only. Means if you compare the fluorine reactivity of fluorine with a interhalogen compound, our fluorine become more reactive, right? Our fluorine, it become more reactive. And in the same way, if you talk about why it is like that, why the interhalogen compound are more reactive than fluorine, because because halogen to halogen bond, X to X dash bond, right? In interhalogen compound, it is it is weaker than X X bond in halogen. Obviously, beta, as a X X dash bond is a weaker, it will become more reactive. X X dash become, what you can say, if it is a uh, if it is a weaker bond, obviously it will be more reactive than halogen. But this case will be accepted only for the fluorine. Means if you'll talk about if you'll talk about uh, now see what I here again I will tell you, interhalogen compounds are more reactive than halogen except to fluorine, because because X X dash bond means in interhalogen X X bond, X X dash bond in interhalogen is weaker than X X bond in halogen, except for whom? Except for the fluorine, right? Other than fluorine. Means if they will ask the question among the interhalogen compound and fluorine, which is more reactive? So obviously fluorine is more reactive than interhalogen compound. But among the XX dash bond and fluorine fluorine bond, which is more weaker, obviously fluorine fluorine bond is more weaker than interhalogen compound, right? It is about the reactivity part. Now, but all these interhalogen compound can undergo hydrolysis. All these interhalogen compound, they can undergo hydrolysis and they can form the compound. Let me tell you beta, what is that? I am having X X dash. Then I will write here as a X X dash 3, X X dash 5, X X dash 7. They all will undergo hydrolysis. Means tendency to react with the water or they can combine with the water. But what is this X indicate here? Just now I told you X is a larger size halogen and X dash is a smaller size halogen. But when they combine with each other, when they combine with each other, they can form the compound called as a hydrogen halide. But this hydrogen halide, the X which is coming, it is coming from the lower, smaller size of the halogen. X X dash, X X dash, X X dash, X X dash. But it is a hydrogen halide where the halogen is coming from smaller size of the halogen. And other byproducts here. If it is a if it is a X X dash, right? If it is a X X dash, but it will form the salt called as a hypohalite. What is a hypohalite? Let me tell you, madam. When it combined to form actually HClO or HXO, it is a salt formed by XX dash. If it is a XX dash 3, it will form HXO2. But XX dash 5, XX dash 5, that means combined with the water it form HXO3, and here it form HXO4. If you want to write the name of this one, it's a very important because we should know the name of this element also. What is the name of this element? But HXO is called as a hypohalous acid. HXO2 called as a HXO2 called as a Halous acid. Hypohalous acid, Halous acid. HXO3 called as a halic acid. HXO4 called as a perhalic acid. But what is a salt formed by them? What is a salt formed by them? I'll explain you better. The salt formed by them is a XO negative. But it is called as a hypohalite ion. What is the salt formed by them? If you take out the H from here, I will get ClO2 negative, means XO2 negative. But here, the name of the hypohalous called as a hypohalite. The name of the halous is called as a halide ion. Then salt formed by them is a XO3 negative. But this XO3 negative, actually it is called as a HALATE halide ion. And here XO4 negative is there. It will be called as a perhalate ion. See beta, if the XX dash type of the interhalogen compound undergoes hydrolysis, it gives hypohalous acid, and salt formed by it is a hypohalite ion. XX-3 on hydrolysis can form halous acid, and salt formed by them it is a halide ion. XX-5 on hydrolysis gives halic acid, and salt formed by them is a halide ion. XX-7 on hydrolysis gives rise to perhalic acid, and salt formed by them is a perhalate ion. So this is about the hydrolysis of the interhalogen compound. But in exam they can ask you the question for the bond length and all. Let me explain you beta. कि I am having a oxy acid of chlorine करके they can ask you oxy acids of chlorine. Beta, what is oxy acid of chlorine? HClO hypochlorous acid, HClO2 chlorous acid, HClO3 that is chloric acid, HClO4 called as a perchloric acid. This will be called as a hypochlorous acid. This will be called as a chlorous acid. It will be called as a chloric acid, and it will be called as a perchloric acid. But among these all, the question is that which is a more acidic in nature? In every exam, this question will be there. Among the following, which is a more acidic in nature? But if you want to see the acidic nature among all, you know, HClO4 is a more acidic in nature than all. So HClO, HClO2, HClO3, HClO4. So HClO4 is a more acidic in nature. But they can ask you chlorine oxygen bond length. So we can say one more point here. Beta. Chlorine oxygen bond length, it will be decreases from the salt formed by it, that is OCl negative to ClO4 negative. And one more point, beta. Chlorine oxygen bond length decreases. That means its bond energy increases from OCl negative to ClO4 negative. See, with a bond length decreases, so obviously its bond energy increases, right? About the oxy acid of halogen. Now they can ask you the structures of this one. So go one by one, better. First one is HClO. What is the hybridization of chlorine? But a very important point. Either it is a HClO or it is a HClO3 or HClO4. But in every case, oxy acid of chlorine may central atom chlorine will undergo sp3 type of the hybridization. I'll show you one example. For example, HClO is there. But in HClO may take out the hydrogen, I will get the salt as a ClO negative. So Cl is here, beta. It is bonded with the O. You know, chlorine is having a 3 lone pair here. As it has a 3 lone pair, now the structure how it look like? Sir, it look like a linear. Then in that one central atom chlorine undergo hybridization sp3. Then HClO2, take out the hydrogen, I will get ClO2 negative. The chlorine, it is having one as a O negative, other oxygen as a double bond. And now out of these 3 lone pair, it has only now 2 lone pair, right? How the shape look like? So shape look like a angular. And third oxyacid of chlorine, one more is there, called as a HClO3 now. And take out the hydrogen, I will get the salt ClO3 negative, Cl 1, 2, and 3. I'll say this is O negative, then double bond O, and one lone pair. You know how it look like? It look like a pyramidal, 3 bond pair, 1 lone pair. And last one is perchloric acid, that is HClO4. Take out hydrogen, I will get ClO4 negative, means Cl bonded with O negative, 1, 2, 3. Double bond O, double bond O, double bond. But here you can see this pi bond of oxygen, it is in conjugation with the negative charge over the oxygen. This pi bond also with conjugation with negative charge on the oxygen, and this pi bond is also in conjugation with negative charge on the oxygen. Hence we can say as it has more conjugation between negative charge and pi bond, it is more stable. But as it is more stable, means can we say HClO4 want to form more stable ion, means it is has a tendency to give H plus and called as acid, and this is called as a conjugate base. And as it has a tendency to form stable conjugate base, so I can say HClO4 will act as a what? Strong acid. So HClO4 will act here as a what? Strong acid. So this is the one of the example which one I have given here. But in exam they can ask you bit of most of the question based on the shape of these molecule only. What is the shape of these molecules and how the shape of the molecules can be explained. But one more point is that this is the only explanation I have given for oxyacids of chlorine. But if you'll go other than that, let me tell you one example is there. Sir, what is the geometry and shape of the molecule formed by XX dash type of the compound? But a XX dash type of the compound may actually geometry we cannot discuss because all these will have a geometry is only a linear one. But another one, but in this XX dash may the most example, important example they are asking in exam, that is CLF. How it look like? So you should say, sir, it is the colorless gas, right, beta? And one more beta, IBR. If you will see, sir, it is the black color of the solid. About XX dash. Another interhalogen compound is a XX-3. But a XX-3 में the most important example is ClF3. Sir, how it look like? Sir, it is also the colorless gas. But see, beta, you should know what is the Z value of Cl here. Beta, Z means it is there in chemical bonding. Z is equal to 1 by 2. Chlorine, number of electrons in the valence shell of chlorine is 7. Plus monovalent how many? 3. 7 plus 3, 10. 10 by 2, 5. Z value 5 means it undergoes sp3d type of the hybridization. Means in ClF3, my chlorine undergoes sp3d type of the hybridization. That means geometry of the molecule is a trigonal bipyramidal. Trigonal bipyramidal means it is having a 3 equatorial bond and 2 axial bond. 3 equatorial and 2 axial bond. But in this one, here, how many lone pair and how many bond pair are there? So find out with this trick. Z equal to number of bond pair plus lone pair. But a bond pair, how to find out? Central atom chlorine is surrounded by how many atoms are there? So three fluorine atoms. So bond pair is three. And to make your Z value equal to 5 beta, how many number I should add? 2. Hence it indicate that this molecule is having ClF3 molecule is having 3 bond pair and it has 2 lone pair. But wherever the trigonal bipyramidal is there, lone pair will always occupy its equatorial position. These position are called as a equatorial position. And remaining fluorine you have to keep here. One fluorine at axial, one is equatorial, one is axial. But this bond is called as equatorial. This is equatorial. This is equatorial. This bond is axial. This bond is axial. And if you see, beta, its geometry is trigonal bipyramidal. But once you try to see the shape, how the shape look like, so it is a T-shaped molecule because here it look like a T shape. So it is about the ClF3 in XX-3. But one more is there, XX-5, XX-5 interhalogen compound. Sir, here IF5 will be there. Beta. Again BRF5 will be there. ClF5 will be there. Beta, it is a colorless gas. BRF5, it is a colorless liquid. ClF5, it is also a colorless liquid. Right, beta? But for all these one, we'll talk about the shape. Let us go with example of ClF3, ClF5. Central atom chlorine get the Z value. Z equal to 1 by 2. Number of electron in the valence shell of chlorine how many? 7. Plus monovalent how many beta? 5. 7 plus 5, 12. 12 by 2, 6. Z value 6 means it is a sp3d2 type of the hybridization. But a sp3d2 type of the hybridization means 3 plus 2, 5 plus 1, 6. That means geometry of the molecule is a octahedral. But if you want to draw the octahedral, we can draw the octahedral in this way. See, octahedral I am going to draw. It is in this way. It is a chlorine 1, 2, 3, 4, 5, 6. But in this one, find out now number of bond pair how many and lone pair how many. See, it is a geometry for the octahedral. Central atom chlorine is there. Right. Now, ClF5 में Z is equal to number of bond pair plus number of lone pair. But how many surrounding atom it has? 5. So bond pair is 5. To make Z value 6, how many number I should add here? 1. So bond pair is equal to 5. Lone pair is equal to 1. And lone pair will occupy here. The remaining bond pair will come to here. But here, if the bond pair are coming, once you check the how the shape look like. Shape means it is something this way. This fluorine coming to here, this chlorine coming to here, this fluorine here, this fluorine here. Overall, if you see the shape of the molecule look like a, yeah beta, shape of the molecule look like a square pyramidal. It look like a square pyramidal. Same way, the last one is there IF7, that is XX-7. Example is IF7, but it is a colorless gas. It is a colorless gas. Here, Z value equal to 7. That means sp3d3 hybridization geometry is a it is a pentagonal by pyramidal geometry and shape is also same pentagonal bipyramidal because number of lone pair in this molecule is equal to 0. So this is completely about the interhalogen compound with the shape of the interhalogen compound we have discussed in the class.